Prashant. Today I am going to start with 9th standard topic known as simple pendulum. This simple pendulum topic is there for our 11th-12th standard also, right? So this has to be perfectly done. Now what exactly is a simple pendulum? In simple pendulum, a point heavy mass called as bob, it is attached with a massless inextensible string with the help of rigid support. This arrangement is called as simple pendulum. So here you have, I have just drawn this diagram. This is my rigid support. This is my rigid support. To this rigid support, I am attaching one massless. This is a point heavy mass called as bob. So this is the bob. This is attached with the help of massless inextensible string. This is massless and inextensible string. Inextensible string. Right? Now this is all these things are ideal simple pendulum. Now this pendulum, this is its mean position. This is called as its mean position. This is its positive extreme position. EP stands for positive extreme position. And here it is minus negative extreme position. It is called negative extreme position. Now what is this L? L is called as, this L is known as effective length. Now why it is called effective length? Now effective length is from rigid support up to its center of gravity. This is the center of gravity of this point. Now what is center of gravity? Center of gravity. This term is there in 10th standard. What exactly is the center of gravity? It is a point at which whole weight of body is balanced. That point is called center of gravity. So this is a regular shaped body. The position of center of gravity will be here. So this effective length is from L plus small r. Small r is the radius of this bob. So length, actual length is from this to this, but when we take the calculation part, it is called effective length, and therefore I am writing purposely it is called effective length, that is from rigid support up to the center of gravity, right? So here this bob is at initially mean position. It is displaced from its mean position to extreme. So here it is displaced from mean position to extreme position. From extreme position it is coming back to mean. From mean again going to negative extreme, and again from negative extreme to mean. This one set is called as one oscillation. This one set is called as one oscillation. So bob is starting from mean to positive extreme, from positive extreme to mean, from mean to negative extreme, and from negative extreme again back to mean position. This one set is called as one oscillation. It is called one oscillation, right? Now I will drop this part and I will just go with what exactly is the time period of one oscillation, right? Now time period of one oscillation is given as, this is T is the time period of simple pendulum is given as T is equal to, it is 2 pi root of L upon G. This is the time period of oscillation, 2 pi root of L upon G, where L is called effective length and G is called as acceleration due to gravity. G is called as acceleration due to gravity, right? Now time period depends on two factors. Right here, factors on which time period depends. Time period depends. It depends on only two factors. One, time period is directly proportional to square root of length. Time period is directly proportional to square root of effective length. So we can write here, therefore, if you increase the length, effective length, time period will also increase. Time period will also increase. So frequency will decrease. Right? The clock will slow down if the effective length is increased. Second part, time period is inversely proportional to square root of g. So we can say if you increase the g, time period will decrease, or if you decrease the g, time period will increase. That is what is the two factors on which time period of simple pendulum depends. Now factors on which time period is independent. It is independent of two factors. What are they? First is mass and material of bob. First point is what? Mass and material of bob. And second is the extent of oscillation. It is extent of oscillation, that is amplitude. These are the two factors on which time period of oscillation depends, and these are the factors on which time period of oscillation is independent. Right? Let's just take the friends. This is the last part of this topic. This is the rigid support. This is the bob which is at mean position. This is the bob which is at extreme position, and this is the bob at negative extreme position. Now, in initial part, bob is moving from here to here, then from here to here, here to here, and again coming back to this. Now, since t is a total time period, so time taken by bob to move from mean to positive extreme is t by 4. From positive extreme to mean, again t by 4. From mean to negative extreme, again t by 4. And from negative extreme to again back to mean position, is t by 4. So this t by 4 plus t by 4 plus t by 4 plus t by 4, that comes out to be t. That is a time t. Right? Now that's it for this video. Please do subscribe and share this video with your friends. And if you subscribe this channel, you will get all the notification. And whenever I am uploading, it is not possible for me to every time I will share this video on groups. But many times I skip that part. For that, please subscribe my channel. Thank you.